So here we are in Berlin, New Hampshire. This is the Androscoggin River, which runs through town. And right near the river there is a paper mill where they're making paper. To bleach the paper, they need chlorine. And to get chlorine, there's a chlor-alkali facility that uses mercury to separate the chlorine from seawater. Some of that mercury, which is green in this depiction, leaks into the environment. Some of that's going to enter the river. Some of that is going to be spewed into the atmosphere where it will eventually be deposited elsewhere in the surroundings. When the mercury gets into the river, it sorbs onto iron oxide that is coating sediment particles. So here I'm showing some red iron oxide with attached mercury in the river.
I'm gonna try to keep it really steady. You can also always speed it up. That would look better than me slowing it down. Okay, Pete.
To power all the paper mills, a series of dams was erected along the Androscoggin in Berlin. This is a look at the river in profile view, with up being this way and this showing the bed of the river. So here's the dam. At low flow, the water comes down and there's a backwater behind the dam where mercury-laden sediment settles out and is trapped behind the dam. However, during high flow events, mercury stays in suspension and makes it over the dam, continuing on down the stream.
During these high flow events, water spills out over the banks and deposits these mercury-laden sediments along the floodplain.
So here's a cross-section of the floodplain. There is iron oxide with mercury attached to it. And the mercury that is closer to the surface volatilizes. So eventually what we're left with is a much higher concentration of mercury deeper down in the soil and a lower concentration at the soil surface. But there is still mercury left at the soil surface.
Even though these chloralkali facilities were shut down years ago, we still observe elevated levels of mercury in the river today because it is being slowly released from sediment laden with mercury that is stored on the floodplain. Here's one of the major ways this happens. During the spring, we have this White Mountain snowpack that's about to melt. This snowpack is laden with a season's full of ions that are all released at the beginning of the snowmelt into the groundwater system. As this pulse of acidified water moves towards the channel, it passes through these mercury-laden sediments, thereby releasing the mercury. And up next, we'll take a closer look at what happens in here. As this acidified groundwater pulse passes through the sediments, it changes the surface charge of the sediments and desorbs the mercury. This releases the mercury into the river.
Helen is snow. Wait, she's holding hydrogen ions. Pete is groundwater. He's holding water. Keith and Smerens are iron oxide particles holding mercury. That blue sheet is the river. You're taking the hydrogen. And then walk all the way off. Yeah, keep going, keep walking. Keep walking. Out, mercury loves dissolved organic matter. As a result, as this dissolved organic matter is flushed through the floodplain, the mercury is stolen from the sediment particles and transported into the channel with this dissolved organic matter. This process happens concurrently with the acid pulse from the same snowmelt event. Pete is groundwater. Helen is snow. Smerens is dissolved organic matter. And Keith is an iron oxide particle holding mercury. And just keep going out. Just keep going.